Let's get today started. Well, what we're going to be working on essentially today is chapter 10. We've been doing a lot of this work, but it's a big thing. So that's one of the reasons we spend so much time on it. We're going to be we're going to be using SALT to find confidence interval. So some questions you do it by hand, which is essentially what we did yesterday and before. And in some cases, pause a little second, and in some cases we use SALT. SALT's much better because it's quicker and you get the results accurately. And let's kind of take you through how we're going to do it. And this is the kind of instructions. So you're going to hit the SALT button. And when you do, along the top, right along here, there's a whole load of choices. Over on the right-hand side, you'll have one called inferential statistics. And that's where you're going to find the confidence intervals. Now, when you hit that one, you're going to have some choices to make. Underneath procedure settings, you're going to choose one sample proportion and later on 2 sample proportions. And then it's going to ask you for information. It's going to ask you for the number of successes, and you put it in here. And the number of trials, you're going to put it in here. So for instance, if you conducted a survey and there was 1,000 people in the survey, then 1,000 goes here. So think of the number of trials as just being the sample size. And then number of successes could be, out of that 1,000, 820 people said, yes, I like Pepsi, or whatever the question was. So that's what the number of successes are, those who said yes to the question. You're then going to pick at the bottom a little dot and you hit it. And the little dot you're going to pick is called confidence interval. That way it knows that that's what you're going to calculate. And then you're going to put in this box what kind of confidence interval you're looking for. In this case, I've said 95, but you could pick any number you like. And then at the bottom, there's a box and you hit generate results and everything that you want will appear. So that's basically what we're going to do. And I'm going straight over to the homework, show what it looks like. Okay, so let's go down to there. Suppose in 2018, 8% of a random sample of 1,000 American adults responded not at all serious or not too serious when asked how serious a problem they thought opioid addiction was in the United States, which is really, really low, because if anyone knows anything about it, that is a big problem. So from this information here, we're going to be using the SALT button, and let's see where we do it. The first question is, the margin of error for a 95% confidence interval for this poll was reported as 3%. Okay, we'll find out how close that is in a minute. Use the approximation for the margin of error as a percent to estimate or to check that that seems reasonable. Now, right at the end of yesterday, we told you there was a formula for calculating what is called the conservative, right, margin of error. I guess they stuck the word approximation in, but conservative margin of error. Can anybody remember what the formula for the conservative margin of error was?
Is it 1 over the square root of n?
It is. So you go 1, and I'm just doing this off screen, the square root of, and in this case, the sample size was 1,000. And the number I'm looking at is 0.031, which as a percentage is about 3% to the nearest whole number, integer. So it's a very quick check, right? So if you were doing it by hand, 3% seems reasonable. Now, on the basis of the reported margin of error, which was in fact 3%, calculate a 95% confidence interval. Now, 8% take away 3 gets you 5%. 8% add 3 gets you 11%. So we're not using salt yet, but it is coming. It then goes on, it says use a more precise formula and blah, 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 and all that stuff. So let's now use salt. So instead of doing it by hand, I hit the salt button. Now, if you click on inferential statistics, let's make this a little bit smaller. Procedure selection, 1 sample. Number of successes, and what was it there? They got 8%, so 8% of 1,000. I'll have to calculate that. That's 80 people. So 8% is 8 people out of 1,000 trials. Hit the confidence interval button and hit generate results. And there's your answer. That's about what, 6.3%, 9.7. So 6.3% goes here, 9.7% goes here. Now, if you wanted to know the standard error, can you see it there? Which is about 0.1% if you round it off to 1 decimal place. So does that seem reasonably straightforward how you would be able to use salt to calculate everything that you would do by hand like we did yesterday, right? Now, maybe the only number that you might have problems with is the number of successes, number of trials. Definitely the number of trials is easy, isn't that just the sample size? But if they tell you it was 4%, then you'd have to convert it into a number, right? What is 4% of 1,000? And that would be your guy. Any questions about that? That would be good. So we are looking at, based on this sample from 2018, since it's a 95% confidence interval, that we're 95% sure somewhere between here and here. And there's our sentence. Okay, let's try 5, just to get practice at doing this. There's a new treatment for a certain disease. They did a 200 patient sample. 156 of them, it was successful. So if I hit use salt, it's 156 out of 200, and they want a 95% confidence interval. So already there, 1 sample. Just double checking. 156 out of 200. Confidence interval, generate. So the answer would be somewhere, what, about 72% up to about 84%. And the standard error would be about roughly 3%. But you can change that 95. Do you want a 99%? Now, try and remember these numbers, 72, 84. I'm going to do a 99% confidence interval. Do you think these numbers are going to expand outwards, or is it going to shrink inwards? What would you expect when I hit generate?
It would shrink.
Right. So you would think if you did a 99% confidence, you would have a smaller interval. If you want to be 99% sure, wouldn't you want more numbers to be more likely to get the right answer in it? So it's kind of the opposite of maybe what intuitive says. Let's see. So it went that way and it went that way. Right, so the interval got bigger because it started at a smaller number and it finished at a bigger number. Let's get this one out of the way. Once you got the hang of these, they're really quite straightforward, I think, because you're really putting in the same kind of data in two places. And the only thing that bugs me is that this book has no imagination. Almost everybody is 95% with a few exceptions, which I don't think is such a good idea. Well, let's try 7. In a national survey carried out away in 2009, 58% of 1,100 randomly sampled Americans said that abortion should be legal under certain circumstances. We're being asked to calculate a 95% confidence interval on that number. So we have 58%. That's going to be a problem. I know that this number is 1,100. That's the sample size. But I want to get the number of successes. So to get the number of successes, I need to know what number of people 58% of the sample was. One of the easiest ways is just to turn it into a decimal and do this calculation. There should have been a times in there. No, you can't type in times. That's interesting. Okay, yeah, no, it won't allow me, right? But you find 58% of 1,100. So I'm going 0.58 times 1,100. And the answer I get is 638. So that might be the only thing you have to do outside of solve, right? You might have to find the number of people. And confidence interval. And this story wants, there's a surprise, 95%, generate results. So the answer would be this decimal. That's interesting. There we go. That didn't. Let's try that again. There we go. Copy. So I've got, I'm having real problems with my keyboard today. Okay, my keyboard is working. Why isn't my paste working? Okay, do it the old-fashioned way, 0.55. And, oh, 3 decimal places, so 0.51. And on the other number, 609. And let's check that I'm doing it right. So round your answer to 3 decimal places. Can you see that sometimes it's percentages and sometimes it's decimals? Is there any easy way to tell that you're putting in that decimal and not 55.1%? Because if you put the wrong one in, it's going to tell you you're wrong, even though you really are right. You just wrote it down the way that they weren't wanting you to write it. So how do you tell when it's a percentage and when it's a decimal that they want? I'll show you a percentage one again. There's one with a percentage in it. And this one has a decimal in it. Did you notice any difference between the two? I'll show you again, last time. You see they put a percentage at the end of the box. That's it. Just look for that. There are other clues. I think in this question, if I find the right one we've just done, I've lost it. How can you lose something quick? There we go. That's a percentage. There we go. And there isn't one here. And the reason you have to be a little bit careful is, couldn't they ask you for a percentage to say 1 decimal place? So if you just read the 1 decimal place part, you don't realize it's still a percentage, right? So they still want 66.1%. Now let's see what question B is. On the basis of this confidence interval, is it reasonable to assume that more than half Americans thought that abortion would be legal? So if you look at this, more than half, would you agree this interval contains nothing but numbers that are bigger than 0.5, which is what half is? And that is, yes, it is reasonable to assume that. In fact, if you were pushing the envelope, couldn't you say it's reasonable to assume that more than 55% of Americans are in favor of abortion? Because isn't the lower end of this limit about 55%? Wouldn't make much sense in this question, but I could go the other side. Couldn't I say that there's also evidence that it's less than 60%? So it's not everybody, right? It's 60%-ish, right? Less than 60, be safe. So anytime you get an interval, there is very often going to be a conclusion based on that, right? Is there evidence to prove this or that? And you have to look at your interval that you've got in front of you. And in this case, is it evidence that it's more than 50? Yes, there is. There, that would be the sentence you'd write. In the survey, 17 answered that abortions should be illegal in all circumstances. And now they want us to do a 95% on this one. So we're now going to do 17% of that sample size to find out how many people were just against any kind of abortion. So this I'm doing off screen again. So 0.17 times 1100. I have to show you this. This can happen. It's okay, but it looks weird. There's 17% of 1100 people. Is there something weird in that answer? Because it's weird to me.
You put 1110 instead of 1100.
Okay. Then that's not what I was looking at. I'll say that's okay. So that one works out well. Can we pretend for a minute, because this can happen. 188.7 is impossible when you're talking about people. But if the 17% was a rounded off value, couldn't you get something a little bit awkward like that? So if it did happen, right, wouldn't you just call it nearest root, whole number, 189 people, right? So if that did happen in your figuring out what percentage said yes, you could do that. So back to our little guy. And here we go. Use salt, and it's going to be 187 out of 1100. Oh, wasn't expecting that. 187 out of 1100. Confidence interval, everybody's 95. So this time it's going to be 14.8 to 19.2. So as a decimal, that's 0.148. And it climbs up to 0.192. I much prefer percentages, but roughly what, 15 to 19%? Couldn't you have questions like, is there evidence in that interval to prove that less than 20% of Americans are against abortion of any kind? Right. Yeah. Why? Because every number in that interval is less than 20%. Could you also say more than this is evidence that more than 10% are against abortion? Sure. Would you agree all of these numbers are bigger than 10%? So the ends are kind of where you go looking when they say, is there evidence to prove, X, Y, or Z? Any questions about this? I'm comfortable that SALT kind of makes your life a lot easier once you figure out, where to put the numbers. Okay. Pretty standard question. Okay, let's do this one. In a nationwide poll, who thought it should be illegal for handheld cellular telephones? 84% from 800. Okay, so 84% out of a sample of 800. Okay, I'm ready. Rock and roll. Try and hit the right buttons here. 0.84 times 800 comes out as 672 people think that it should be illegal to do cell phones and driving. It's amazing that it's that small. Confidence interval, I believe it's 95, always is. Yeah, no imagination again. Here we go. And what do they want? They want decimals again. And how many? 3 decimal places. So this guy is 815. And the other one is 865. And then they go and ask you to get a 98% confidence interval. Well, at least that's different. If you want a 98, can't you just change one feature, which is that, and then generate new results? And now it's 0.8, 809 and 870. Have you noticed that this interval is a little bit bigger, right? The 98% interval, these numbers here, are a little bit bigger than that one. And the logic for that is, if you want to be more sure, don't you have to have a bigger interval to be more sure that you've got the right answer in it, right? I mean, if you wanted to be 100% sure, wouldn't the interval be from 0 to 1? That's the only way you can be 100% sure. If you want to be 89% or 95 or 98 or any other number, that's what you would do. And they talk about which interval is wider, and it's pretty obvious that the 98% is wider than a 95. If I did a 99, wouldn't it be even wider, right? It would go a little bit bigger to accommodate the increase in how confident you want to be. That's a standard one, standard one. Okay. In a random sample of 275 Americans, 32% said that they always did something. What do they always do? They always ate dinner with their family. Okay, so 0.32 times 275, that ends up being 88 people. So 88 out of 275 is all I need. Okay, bring this guy over. Right, are you seeing 2 screens side by side? Okay, says mail this back in and throw in stuff. So it's going to be 88 people out of 275. And the confidence interval could be 95. Let's do the 91, which means the one that goes here. So I'll generate the results. And this number here is the one that goes there. And this number here goes here. And I believe they want the answer to 3 decimal places, so I'll just round that off to a 4. And this one stays as a 6. Now, if you wanted to get, for instance, the standard error, it's on this screen. You just have to scroll to the right, which I'm not sure I can do because the bottom's missing. See if I can make it happen. There we go. And if you just scroll, there's your standard error. Hopefully. I caught that guy. And to 3 decimal places. And that's pretty much, I think, all you need to know on how to use salt on a single proportion. Would you agree every question is pretty much the same, right? Same process, hit the same buttons, interpret it pretty much the same way. So we're now moving on to the second and final situation, which is how do you use salt to do the difference between 2 proportions, right? So it'll take me a little while to just clear some things up. Right, it's going to take me a few moments to do this. So why don't you do your attendance while I'm doing this? Means that when we finish tomorrow, it'll be a minute quicker. Okay. The process is going to be just an adaptation of this one, right? So it's going to be, hit the same kind of buttons. The information you're going to be giving is almost identical. There's just going to be one slight difference. And that slight difference is here. Because when you do 2 proportions, aren't they going to be 2 different sets of data? One from the first group, one from the second group. So you're going to end up putting in 2 sets of information. So let's do a little story and then we'll show you salt doing it. So just like yesterday, we have 2 populations. In this one, we're going to have Americans. And this one here, we're going to have French. Change of countries. We're going to do, in the Americans, they asked a sample of 500 Americans. How many of you have ever been to Italy? Unusual question, but we asked them. And the answer came out at 11%. Because if you're in the Navy, isn't there a big naval port in Italy? So a lot of people who end up that way do drop into Italy somewhere. Is it in Naples? Not if it's not a secret.
I believe there's actually 3 bases over there.
And one of them might or might not be Naples.
Naples is one of them.
Okay. So not that unusual, right? So if it looks a bit high, I don't think that is. And then they went to the French, and we'll call them N2, of course. And for some reason, there's 1,000 of them. And we found out that the proportion of them who had been to Italy was 15%. No one at 15. Yeah, 15 should work. In real life, that would be a lot bigger. I wouldn't be at all surprised if the percentage of people in France who'd been to Italy was like 80%. I mean, the place is right next door, right? You could virtually fly there in an hour. I mean, I flew to I flew to Rome in 2.5 hours from Glasgow in Scotland. So it's not a big flight. So what we're interested here is to compare these two populations. So we're interested in their difference. And we want to do a 95% confidence interval. But we don't want to do it with all that extra hard work. Remember that horrible standard error formula and all the numbers and multiplying by 1.96 to get the margin of error, you know, and lots of other stuff. We just want to take this and let salt do the whole thing, right? Now, the only thing that's missing is that that number isn't the one I want. Don't we need this guy called the number of successes? So I'm going to find what 11% of that is, and it's basically 55. And all you need to do is multiply. And there is the 55 that we're going to use. And for this one, if you multiply, you'll find out that this number ends up being 150. Okay, so let's go hunting for salt. Right, don't worry about this. This is a different story. We'll do that later. Let's click on this one. Bring salt over. And inferential statistics, right? You got that one. Click on this, but now choose two sample proportion. Does not kind of make sense. You need a different setup. And you have population 1 and population 2. So population 1 in your case was Americans. And 55 out of the 500 that you asked had been early. And population 2, the French, it ended up being 150 out of 1,000. That's pretty easy. I mean, that's almost intuitive. If I never showed you that, you could play about with it and you'd probably find it. Guess what? Hit confidence interval. We have no imagination, so we'll make it 95 and then generate results. And yes, this interval does have negative numbers, and I'm going to turn them into percentages. So the first one, which is this lower limit, is a negative 0.08. So, and it's, no, that's probably not a good idea. It's negative 0.075. This is a decimal version first, and then negative 0.005 if you go the other way, right? So, if you wanted to do the standard error, they don't actually tell you the standard error of the difference. Do you see they only tell you the standard error of each one? Which I think is a pain in the butt, because it wouldn't be that hard, would it, for them to tell us the standard error of the difference, which is one that you're probably more interested in. So I guess that is a little bit different. But they do tell you that the difference in proportion is negative 4%. So that's something. Well, let's hurry back to what we have just found out. As a percentage, that is negative 7.5%, and this is negative 0.5%. Now, we talked Monday and Tuesday about this. If you have the difference in two proportions and all the numbers are negative, as they are here, does that mean P1, is that evidence that P1 is bigger than P2, that P1 is less than P2, or is that just inconclusive because you can't tell? Which of those three can you interpret from this result?
P1 is less than P2.
Agreed. That makes sense? So what's that saying? It's saying the percentage of Americans who've been to Italy is significantly less than the percentage of French. In other words, we proved something that we kind of knew anyway, but now we've got statistical proof. And if it was put to a push, wouldn't you say it's not that different, really? In statistical terms, we agree it could be as little as just 0.5% difference. It could be as much as 7.5%, but on the more generous side, it would only be a little bit like 0.5%. So there is a difference, and that difference is that the first group is less than the second. So I have a joke in my head now that I have to get out. So here it goes. Scotsman, Frenchman, and an American are on this military aircraft flying from Europe to America. And halfway across the Atlantic, the pilot gets on the radio and says, we're in real trouble, we lost a lot of fuel, we're not going to make it, we're going to end up crashing into the sea and we're all going to die. And we don't have any parachutes. And we've got to lose some weight, so we need a volunteer. So the American and the Frenchman and the Scots guys, they just stare at each other, and they stare at each other. And finally, the Scottish soldier gets up and said, oh, I've had enough of this. And he goes to the side and he opens the plane door and he shouts, for the glory of Scotland, and he jumps out. The guy in the radio gets on and says, that's great, we lost a lot of weight, but we're still too heavy, we're not going to make it. I need a volunteer. And so the Frenchmen and the Americans just stare at each other and stare at each other, and nobody's budging. Finally, the American soldier gets up and says, I've had enough of this. And he goes over and he opens the door and he says, for the glory of America. And he throws the Frenchman out.
Kind of saw that one coming.
Did you? Evidently the Frenchman didn't. Oh, I feel so much better when I inflict pain on my students with my bad jokes. Although I do think Mark was nodding, so he didn't see it coming, or he appreciated the joke anyway. We got our thumbs up, okay. So all I want to do now is do a few more examples of that. You know, practice makes perfect. So we're going to go in and we're going to look at some of the homework from chapter 10 on difference between two proportions. Should warn you that you know, there's a weird one at the start, so let's get that question just out the road. Here is question 1, the weird one. Oh, wait a minute, you can't see it, can you? Right, here's the weird one. In this weird one, you're not using salt, right? There is no salt button. And the reason is that all the information that you need for this is actually here. So they haven't used salt, but they've used, you know, some statistical there's lots of statistical programs out there. If you ever do statistics as a career, there's SPSS, statistical packages for the social scientists. There's Minitab. There's just tons of stuff. Excel can do a lot of statistic stuff as well if you get into it. So in an ongoing nationwide survey, a question asked is whether respondents favour or oppose capital punishment, right? So are you in favour of the death penalty? The output for this compares the proportion who said they oppose the death penalty. So they're looking at 2 snapshots in time. In 1993, 333 people out of the 1,418 that they asked were in favour of it. And that was, about 23.5%. In the year 2000, a different sample, you ended up with what? Actually an increase, agreed. So people have become more in favour of the death penalty. Maybe it's a reflection that during that time period, maybe violent crime was increasing, and maybe that's the influence that caused that. Now, a lot of the numbers here involve you looking here and finding them. So that's kind of what they're doing. So what proportion were opposed to it? Oh, this is opposed. So copy this guy, put that in there. What about the other year? Put that guy in. What's the difference between the two? Well, it's there. Can you see it? And I'm basically just looking here and putting down the number for whatever it is they're asking, right? So if I scroll up, what is the 95% confidence interval? God, it's almost in front of me. Oops, can't do all of that. Let's do that side first. This side. And I misinterpreted that. It's not the people in favour of it, it's the people who were opposed to it. So in fact, it's become less popular rather than before. And then you pick one of these, what does that mean? And which one of those horrible formulas is actually the one that you would use if you did it by hand? Now, there's one guy missing here. Do you see that little thing here called Z star? That's the 1.96 or the 2.64 or the 2.58, depending on the confidence interval. So that Z star is just a placeholder for one of those three numbers that I mentioned. So which one of these guys, 1, 2, 3, 4, or 5? Which one of those 5 things would get you
4.
Agreed? Right. And now put in the numerical values. Well, it's a 95%. Can anybody remember the magic number for 95%? What was it? Oh, you don't have a choice. They're all 1.96. They should have at least gave you a 2.58. So there we go. Okay. So would you agree that question wasn't a salt question? It was really somebody else did it and you just read the numbers.
You clicked the wrong one.
Did I? Oh, that's not a surprise. Did I? I did, didn't I? I just thought it'd be the same place. Okay, let's do this one. A study was done to determine whether there is a relationship between snoring and heart disease. So I'll have to write these numbers down. In the snorers, 87 out of 1,105 had heart issues. And only 23 out of 1,379 who were not snorers had heart issues. And we are going to do a 95% confidence interval of the difference. And P1 is going to be the snorers and P2 are the non-snorers. Okay, I got everything I need. Click on this guy. Let's set up salt with everything that we need. So, to sample already done. The snorers go first, so that's 87 out of 1,105. Non-snorers, 23, 1,379. Yep, 95, generate results. So, this guy, and I take it back. That's the standard error. They just put it in a different spot. So they do give you the standard error. So lower limit is going to be that number. upper limit is going to be this number. And 3 decimal places then make this 445. And 3 decimal places makes this 79. And a little question at the end. On the basis of this confidence interval, can we infer that the population proportion with heart diseases differ from non-smokers, non-snorers and snorers? Yeah, I would have phrased that differently. In fact, isn't that evidence that people who snore have a higher incidence of heart problems? And roughly 4% more, agreed? Because this interval has nothing but positive numbers in it. Now, if that was true, there might be some really minor news article. You know, you're 4% more likely to have heart issues if you snore. I don't think snoring causes heart issues. Couldn't snoring just be a confounding variable? Maybe people who snore because they're overweight. You know, if you're overweight, you're more likely to snore. And aren't overweight people more likely to have heart issues?